Hello and welcome to Physics with Amol sir. This video is for class 9 and we will continue with our chapter Force and Laws of Motion. So previously we have seen the three laws of motion. I hope all the three concepts were very easily understood. And we have also seen the concept of momentum. I hope you remember what is momentum. Momentum we define as the product of mass and velocity, or we can define it as the total quantity of motion in an object. Okay. Today we are going to see a very important principle which is known as the principle of conservation of momentum. Okay. So there is a principle in science, in physics, that the momentum of an isolated system is always conserved. Now many new words you would have heard. One you would have heard is conserved, but I am sure conservation, conserved, this word you have heard before. When we talk about we should conserve water, or we should conserve our forests, or we should conserve wildlife. Okay, so that is where we have heard the word conservation. So basically conservation stands for saving. Okay, so when we say a particular quantity is conserved, that means it is saved, it is constant, it is not changed. Okay, and other word you would have heard is isolated system. Okay, so this principle says that if we have an isolated system and there is no external force, then the total momentum is conserved. Isolated system means a system. Now system could be anything. For example, if we are doing our experiment in our lab, okay, then whatever we are having in our in front of us, that can be the system. Okay, or if we have a box, in that box we have put number of things, that can be a system. Or we can also say we are standing in a room. Okay, whatever is the air in the room materials, that can also be considered as a system. Isolated system means which is cut off from the external surrounding, which is not affected by the other surrounding. Okay, so if we have an isolated system, the total momentum is conserved. Okay, now don't let all those words confuse you. We will see the simplest way to understand principle of conservation of momentum. Okay, to understand principle of conservation of momentum, we are going to talk about colliding bodies. Colliding means which are going to come and hit each other, that we call as colliding bodies. So here we will see there are two objects. Okay, let us call this object as A and the other object as B. Okay, now again I am saying we are doing this to understand principle of conservation of momentum. So we have two bodies A and B. Let A have a mass m1 and B have a mass m2. Okay, then we are going to give some kind of forces to both A and B, so that they will start moving towards each other. So we see that A is moving in this direction towards B and B is moving towards A. The principle of conservation of momentum says that if there is no other external force acting, okay, if there is no other external force acting, then the total momentum of these two balls, okay, total momentum before collision will be equal to total momentum after collision. Okay, I think now that is easy to understand, because what is going to happen? A and B both are moving towards each other. After some time they will hit each other. After hitting they will start moving in opposite directions, because they are going to apply forces on each other. Okay, that is where the principle of conservation of momentum comes in. It says that total momentum before collision is equal to total momentum after collision. So that is the statement that you will write for a system of two or more colliding objects. If there is no external force, then total momentum before collision is equal to total momentum after collision. Okay, so this is a statement for the principle of conservation of momentum. Now let us understand it. So as we said before, A and B are both moving towards each other. Okay, let A have initial velocity u1, B have initial velocity u2. They will come and they are moving towards each other. Then after some time they will collide, they will hit each other. After hitting, they will start moving away from each other. After hitting, now A will get velocity v1, that is final velocity, and B will get velocity v2, which will be final velocity for B. Right? So what will the principle of conservation of momentum say? Total momentum before collision is equal to total momentum after collision. How do you find out total momentum before collision? Let us call it as the initial momentum. How do you find initial momentum? So initial momentum of A will be m1 u1, correct? What will be initial momentum of B? m2 u2. So m1 u1 plus m2 u2, this is going to be the total initial momentum. Fine. What will be the total final momentum? The total final momentum will be, for A it will be m1 v1 and for B it will be m2 v2. Okay, so the total final momentum will be m1 v1 plus m2 v2, and principle of conservation of momentum says that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is called as principle of conservation of momentum. But remember, provided that there is no external force acting, that is A was moving with u1 and B was moving with u2. After this, no another force came into the picture. If that is the case, we get initial momentum equal to the final momentum. So this is how you can write down the mathematical form of principle of conservation. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This we have written for two colliding bodies. It is applicable for n number of colliding bodies. Okay, even if we have let us say 100 bodies, we would have written m1 u1 plus m2 u2 plus m3 u3, so on and so forth till m100 u100. Okay, so no matter how many bodies are colliding, the total momentum before is equal to total momentum after the collision, provided there is no external force. This is called as principle of conservation of momentum. So I hope that concept was understood. Now the task for you is, you are going to memorize the first law of motion, second law of motion, third law of motion, and principle of conservation of momentum. All these definitions should be understood. Next, you are going to memorize the important formulae. Formulae for momentum, formulae for force, okay, and the formula of conservation of momentum, right? In the next class, we are going to discuss the numericals on this chapter. For chapters like these, numericals are to be expected, okay, because we have got a lot of formulae. But for that, first you should understand all the definitions, okay? So once again, go through all the definitions. Make sure that you understand each and every one of them. If there are any doubts, make sure that you are asking me. Okay, so now I'll see you in the next class, where we are going to discuss all the numericals for this chapter. Thank you.